Alright, so we're going to do derivatives from an equation. Or derivatives algebraically. So our derivative tells you slope. And if we're taking the derivative of an equation, we want something that's going to give us the slope of like the entire equation. So let's do a couple examples and kind of think through a couple, and then we will... There's 3 rules that you would need to know how to apply. So let's say I give you y equals 8. What kind of line is horizontal? What kind of line is y equals 8? And don't say straight. Horizontal, right? So what's the slope of that line everywhere? Not 8. 0. Because it's horizontal, right? So the slope of that line is 0. So what should the derivative be? It should be 0. The derivative is there to represent the slope of that line. So the derivative of 8 would be 0. If I had y equals negative 11, what kind of line is that? Horizontal. What's the horizontal line? 0. What's the derivative? So, here's one of your rules. If I have y equals k, where k is a constant, what's the derivative? 0. Because that's just a horizontal line. And a horizontal line has a slope of 0. So the derivative is 0. For those of you that can't see, that was Jonah Priest that just fell out of his chair, basically. Let's say y equals 5x. You okay? Okay. What's the slope of that line? 5. So what's the derivative? 5. Y equals negative 10x. What's the slope of that line? Negative 10. What's your derivative? Negative 10. So our rule there is if y equals kx, what's our derivative? Okay. So that's 2 of the rules. The third one's not really as easy to you won't really be able to come up with on your own. But let me give you a couple and see if you can come up with a pattern. So if I gave you 3x squared, your derivative would be 6x. If I gave you 5x to the 4th, your derivative would be 20x to the 3rd. If I gave you x to the 1/2, your derivative would be 1/2 x to the negative 1/2. So then can you fill this in? If y equals k times x to the n power, y prime equals what? So take a second and see if you can see the pattern type thing that's happening there, and then maybe fill this in. So like if I look at this one, where'd that 6 come from? 3 times 2, and then what happened to the power? 1 less, right? So where'd the 20 come from? There's the 4 times 5, and what happened to the power? Down by 1. Where'd the 1/2 come from? The 1/2 times the 1 that's in front, power decreased by 1. So if you have, bless you again. If you have k times x to the n power, your derivative is going to be n times k. So you multiply the power times the number in front. You leave the x, and what's your new power? N minus 1. And that's your derivative algebraically. So it's not looking at a graph and doing the slope or whatever, but it's telling you that same information just from an algebraic perspective instead of looking at the graph. So that opens up like a whole new thing that we can do. So first is like, just can you take the derivative of different things, and then we'll start applying it in different ways. But let's say I gave you that. If I ask you to take the derivative, you've got three separate terms there, and what you're doing is just taking the derivative of each of the three separate terms. So if I ask you to take the derivative of 4x squared, what would you tell me? 8x. So 4 times 2 is 8. Reduce the power by 1. If I ask you to take the derivative of negative 3x, what would you tell me? Negative 3y. What kind of line is y equals negative 3x if we just looked at that by itself? No, it's got a slope of negative 3, right? So what's the derivative? Negative 3. What does y equals 8 look like? Horizontal line, so what's the derivative? 0. So I don't need to write that part. It's just going to be y prime equals 8x minus 3. All right. So do this one. I mean, I don't think this will be tough, but the fractions might screw people up. I don't know. Is that better? So again, you got like basically three separate problems in one there. You're doing them just one at a time. So the derivative here would be bring down the 4 times 10 is 40. Reduce the power by 1. That's pretty basic. Here you're bringing down the power and multiplying. So remember that's 5 over 1. And then you multiply straight across. So that'd be 10 thirds x, and then reduce the power by 1. So fourth. And then here, if I bring down the power, it's negative 1 times 8, which is negative 8. And what's 1 less than negative 1? Negative 2. And then that'd be your answer. How many had that? Okay. Remember, if I have that, let's say the mth root of x to the b, if I ask you to write that without the radical sign, so like x to a certain power, would it be m over b or b over m? It's b over m. It's always the inside over the outside. So this would be x to the b over m power. So they'll ask you things like, take the derivative of the third root of x squared minus the square root of x to the fifth. So if it's square root, like if I didn't put a number there on the outside, what's really there? A 2, because it's square root. If I didn't put a number on the inside, what's really there? A 1, because it's x to the first power. So if I gave you that problem, the first thing I would do would be rewrite it. So it's x to the 2/3 minus x to the what? 5 over 2, 5 halves. And then take your derivative. So you just got to like set it up the way that it would work out best and then go from there. So this would be bring down the 2/3, reduce the power by 1. So that's 2/3 minus 1, so it's like 2/3 minus 3/3, which is a negative 1/3. Minus, so bring down the 5 halves, multiply by the 1 in front, so it's still 5 halves. Reduce the power by 1, so 1 is really like 2 halves. So power would be 3/2. Question on that guy? Anything? Maria, you good? You're not good? Are you good on the understanding? Just not the... Okay. Is everybody still writing? All right. Do this. I'm throwing a little twist at you there. I would rewrite it first, and I would rewrite both of those. You cannot take the derivative in the form where x is on the bottom there. So what else can you do with this? If you bring it up to the top, what does it become? X to the -2. So if I bring a power up from the bottom, or switch directions either way, top or bottom, it changes sign. So that'd be your rewrite, and then do your derivative. Is it 28 or 22? Okay. I ask you that like every day, don't I? So your derivative, remember you just rewrote it. So these two are actually like the exact same thing. You just wrote it a different way. So some people get to here and they're like, oh, I accomplished something. Which you kind of did. You rewrote it in a better way, but you didn't take the derivative yet. So bring down the 3/4. Subtract 1 from that, so you're subtracting 4/4. So -1/4. -2 times the -10 in front makes it +20, and reduce the power by 1, so -3. How many had that? Good. All right, one more thing I want to look at. Let's say that I have... I want to say this. Okay. Tell me what that equals. If I add all that up and divide it and work it all out, what number does that come out to be? You guys agree with 9? 5 plus 15 is 20. So 25 is 45 divided by 5. This is going to be 9. I want to rewrite that in another way that also gives me 9, so like that it means the same thing. And I'm going to show you a couple wrong ways and why they're wrong. But some people will try to bring this 5 up to the top, which I don't ever... That's not wrong. But if you're dividing and you bring it up, what's the opposite of dividing? Multiplying. But wasn't every single thing in here being divided? So if you're going to multiply, what do you have to do? Multiply by every single thing. So one way you could rewrite this would be like that. So I'm taking that 5 and throwing it up and then changing the power. So what's 5 to the negative first? 1/5, and then 1/5 times 45 would be 9, right? That way is fine. I also, as long as you realize that you're multiplying by like everything in there, I also could, okay, all those things are being divided by 5. So what if I separated out 3 fractions? So I'm kind of doing, I'm adding fractions but backwards. I'm like unpacking it into 3 separate fractions. Does that also equal 9? What's that? 1, 3, 5. Add those up. You get 9, right? So that's another way you can like unpack it. I'm not going to show you the wrong ways because I don't want them to be in your head. You might come up with them on your own though, we'll see. So if I give you like x squared plus 3x over x, let's say, and ask you to take the derivative. So we don't currently have a way to take the derivative if there's an x on the bottom. So there's 2 ways I can fix it, and it's the 2 I just went through. You could rewrite this as x squared plus 3x times what? x to the negative first, so I'm going to bring that up. And then I would multiply those out, which I'll get to in a second. You could also split up your fraction and say, well, that's x squared over x plus 3x over x. The question is, which one of those do you think is easier to simplify? And that answer is different for everybody. You can do it either way. Yeah. You can. That doesn't always work, so I'm just kind of trying to show like a more general thing. In this situation, yeah, you could just be like, okay, that's essentially what this is, though. You're taking an x out here because you would just go x plus 3. But in situations where that doesn't work, I want you to know how to, you know what I'm saying? This, I think, is harder, but some people like it better. I don't know. So multiply x to the negative first times x squared. What do you do with the powers when you're multiplying? You add them. So that'd just be x to the first. And then x to the negative 1 times 3x. When I add up those powers, what would I get? 0. So what's x to the 0? Well, x to the 0 is 1 times 3 is 3, right? So to me, this is easier. But that other way is not wrong. I'm just giving you like alternatives. You can do whichever makes more sense to you. So let's say I gave you I gave you that and ask you to take the derivative. So try that. So this is even more, I think this way is just so hard because if I bring 3x up, you would actually have to write this like 1/3 x to the negative 1. Because the 3 there's really a 1 on top of it, so it's 1/3. I think this way is so much harder. I would strongly recommend the other way, but you can do this way if you want. So if I'm doing it that way, because really the only thing, if I do it this way, the only thing I'm bringing up is the x, and the 3 just is rewritten as 1/3 instead of like 3 on the bottom. And you can multiply through, and you can get what you're supposed to get, which would be that. I just think it's way harder than the other way. The other way would be, let's just separate the fraction out, write them each individually over 3x. And then I think for almost everybody in here, simplifying these 3 fractions is easier than distributing into there. I think, but I could be wrong. If I divide here, I get x squared. Here, those cancel. One of them cancels, I get 4/3 x. And here that I get that. And now we're not done yet, right? So all of that was just to like rewrite it so that's in a form we can do something with it. Again, I prefer this way, but I'm not going to force you to do it. But we're not done. We still have to take the derivative. So what's the derivative of x squared? 2x. What's the derivative of 4/3 x? 4/3. What's the derivative of negative 8/3? 0. Why? Because that represents what? A horizontal line which has a constant slope, but more importantly, a slope of 0. And this is the answer that I want you to get to. There's just kind of 2 ways to get to it. Is anybody doing this way, like the multiplying way? Does anybody like that better? You're good with it? Okay. Are there questions? Any questions? So, I'm not going to give you any homework tonight because I'm not going to be here tomorrow, so I'll put a worksheet on there for you to practice tomorrow.